And I guess it's evening. Good evening, mathematicians. All right. In this video, I will be walking you through the Unit 3 test review. Obviously, I would like you to do this before you watch this video. At least try it, okay? And then correct things as we work through it together, okay? Well, with that, let's get started. Okay, so we're given a table. They don't really give us anything else. So we know that there are years and there's population. For years, you guys, it's really important that you don't plug in the actual years into your equation when you write them, okay? You should be plugging in things like 0, 1, 2, 3, 4, and 5, okay? Because if you plug in 2000, that's a completely different thing, and you will definitely get the wrong answer. Okay, but let's go through this. Question A, it's asking me to find the growth factor. Now remember, the growth factor can be found if you take 1 year, maybe not the first year. Let's do 57, and you divide it by the previous year. So we're going to do 57. Actually, I should be writing underneath the question. So 57. We're going to divide it by 30, and that should give us our growth factor. So if you type that in the calculator, 57 divided by 30, and that gives me 1.9. You can try another one. Let's do 108 divided by the previous year, which was 57. Let me see what this equals. 108 divided by 57. That equals 1.894. I'll do it one more decimal point. So as you try all of these, which I don't require you to do, you'll notice that it gets a little bit further away from 1.9. You start getting like 1.894, 1.89 something, and they all kind of revolve around the number 1.9. So if you write 1.9, I am fine with that. So your growth factor is 1.9. Okay. Now we need to write an equation that models this population. So remember, this is what we talked about in class the other day. There are two equations that you can use. There's y equals a times b to the x power, or y equals a times b to the x minus 1 power. And it really depends, which equation you use depends on what we start with. Well, if we take a look back at our table, we start with 0. Okay, we start with a 0 term. So because we start with 0, that means we're going to use the equation on the left. Okay, so there are two things that we need. A is our initial value. What is our initial value? Well, that's 30. So I'm going to go ahead and write that in for A equals 30. And B is our growth factor. We said that was 1.9, and we're just going to plug things in. Y equals 30 times 1.9 to the x power. And that is your equation. All right. Now that we have this equation, that's going to help us answer the next few questions. So let's take a look. What will the population be in the year 2008? Like I said earlier, we are not going to plug in 2008 for x. Instead, how many years after the year 2000 is 2008? Actually, this is going to be 8. So we're going to plug in 8 into our equation. So y equals 30 times 1.9 to the 8th power. So let's type that in. 1.9 to the 8th power times 30. You're going to get a number like this, 5,095.06. But since we're talking about population, like actual numbers of people, we'll get rid of this 0.06, and we will say that the population is 5,095. Okay, next one. When will the population reach 1,000? So this is when our y is equal to 1,000. And this is a little like a guess and check type of game. Okay, use the table to your advantage. Well, we know that after 5 years, we're going to be at around 743 people or whatever this population represents. So we definitely know that in order to reach 1,000, it needs to be more than 5. We just checked the 8th year, and that's about 5,000. So good ideas to try would be probably x equals 6 and x equals 7. Well, let's try x equals 6 first. So y equals 30 times 1.9 to the 6th power. Let's try that. 1.9 to the 6th power times 30. And that's going to equal about 1,411. So we actually don't need to go much further than that. What we need to say in our answer is between 5 and 6 years, the population will reach 1,000. And that's our answer. Okay. All right, let's keep going. Okay, in 2009, Ms. Howe opened an IRA account for $1,000 and did not add or take out any money after that. The money grows at a 4% rate annually. Okay, so we got some important information here. We have $1,000 and we have a growth rate there. So we need to make a table to show how much money she will have on 2017, maybe in 2017. Okay, so let's start off with writing 2009. So 2009, we need to treat this as the very start. This is the very beginning year. So we actually would plug 0 in for 2009, right? This is our starting point, okay? And then we're going to figure out how much money she's going to have in these next 2 years. So let's go ahead and write in some of the years here. 2010, 11, 12, 13. Are we going to end in 2017? Yeah, we'll actually go into last year, 2018. Okay, and the values we will be plugging into our equations are not these numbers, but we are going to plug in 1, 2, 3, 4, and 5, etc. respectively, okay? So please pay attention to which numbers you are plugging into your formula. Okay, so we start with $1,000. And we know that this money grows at 4%. One way you could do this is you could actually just take 4% of 1,000. So if you do 1,000 times 4, or 4%, sorry, 0.04, you get 40. Right, and this is how much she's gaining each year in this account. So in the next year, we're actually going to get $1,040. Okay, and then and be careful. You are not going to add $40 for each year because that's not correct. Instead, what you're going to do after each year, you're going to take the value and then you're going to multiply it by 4%. So let's see, 1,040 times 0.04, and that's going to be 41.6. And then we're going to get something, we're going to add that to our original amount. So 1,040 plus 41.6, it's going to be 1,081.60. Okay, so be very careful. Very careful here. And the other way that you could do this, some of you might actually just want to find the growth factor before doing this table. Some of you might want to find the growth factor, and that's okay. We could do that. So we know that the growth rate is equal to 4%. Now, in order to convert this, we have to change 4% into a decimal and add 1. And our growth factor is now 1.04. So we're going to be multiplying by 1.04 each year. And this will help us figure out our values as well. Okay, so let's do 1081.6 times 1.04. Okay, and we're just going to keep going. We're just going to keep multiplying by 1.04. So now I have something like this. 1,216.65. And remember, we're dealing with money, so we should have only 2 decimal places. Almost done here. Last one, 2018. How much did she end up with last year? $1,423.31. And there we go. Okay, we need to make a graph of our data. Ooh, sorry we didn't give you guys a coordinate plane here. So you guys are gonna have to create your own. Okay, but the same things still apply. I still want you to label your axes. So here, this is number of years. Okay, and then the x-axis, or the y-axis, I'm sorry, is the amount in dollars. Okay, and then let's see. What can we do? So I think what I'm going to do is I'm going to start with, on the y-axis, I'm going to start with 1,000. And then I'm going to go up by 400. So now I have 1,400. Oh no, that's too much. Sorry. Excuse me, not 1,400. I'm going to go up by 100s. So 1,100, 1,200, 1,300, 1,400, 1,500, etc. Okay, and then we have this little. Okay. So I forgot to put in these numbers. And there we go. Okay, so now we have something we can graph. So at year 0, we are at 1,000. Actually, here, let me do this in a different color. Year 1, we only moved up slightly. Fourth year is 1,169. 1,216. 1,265. 1,315. 1,368. And 1,423. Okay, so that's as good as it's going to get. Again, when you're graphing this, I just want you to be accurate. Okay, so I don't want to see any straight lines. Please, no straight lines unless it is a linear function. Okay, most likely these are going to be exponential functions and they must be a curve. Okay, otherwise I will not give you points for a straight line. Okay, and now we come to the last question. Write an equation for the value of the account after any number of years. So remember to define your variables. So we could say A is the amount in the account. And we can say, let's say Y is years. I'm a little wary about using Y. Okay. So we know that our initial value was what? $1,000. We know that our growth factor is 1.04. And did we start at 0? Why, yes, we did. So we're going to use this form, a times b to the x power. All you got to do is plug it in. So we're going to replace y with a, capital A. So the amount in the account is equal to $1,000 times 1.04 to the x, oops, not the x power, excuse me, to the y power. Okay, and that is our equation. All right, moving steadily along. Okay, Miss Ayudi opened a savings account of 10,000 what? Probably dollars for her son and instructed him to only take out 20% each month for the first 6 months. So it looks like we're going to have months as our inputs and amount being our output. So at the very start, right, no time has passed, so we can say that is at the 0 month. Okay, and we're going to go to the 6th month, 2, 3, 4, 5, and 6, and we want to find the amounts for each of these months. So let's take a look. We have $10,000 to start with. It would definitely help to look at this, what I just highlighted. Not the 10,000, but the take 20% out each month. Hopefully you realize this is going to be an exponential decay function. Okay, so it looks like our decay rate is 20%. Now, to convert this into a decay factor, we have to change, I'm going to bring it over here, change 20% into a decimal, so that's 0.2. And then we're going to subtract 1, we're going to subtract from 1. 1 minus 0.2 is going to give us 0.8. So our decay factor is equal to 0.8. Okay. Let's go ahead and use 0.8 to our advantage here and fill out this table. 10,000 times 0.8, it's going to be 8,000. 8,000 times 0.8, it's going to be 6,400. That times 0.8 is 5,120. That times 0.8, I think you're starting to see what we're doing here. 4,096. That times 0.8 is $3,276.80. And that times 0.8 for the final value is $2,621.44. All right, so let's write an equation. The equation we are going to use is y equals a times b to the x power because we start at 0. Our a is equal to 10,000. Our b, our decay factor, we said was 0.8. Okay, and let's see, do they tell us which variables to use? No, they don't. So really, it's up to you. I just need to be able to know which one's which. So if you're going to use y and x, tell me that y is equal to the amount, and x is equal to the number of months. So now when you plug it in, y is equal to 10,000 times 0.8 to the x power. And that is your equation. Continuing on, in what month will he have less than $2,000? Well, we know that in the 6th month he's going to have $2,621. So let's see what happens if we try the 7th month. So when x is equal to 7, so we could take 2,621.44 times 0.8. So let me actually write out what I typed into the calculator, because that's what we should be doing, times 0.8, and that's going to give me $2,097.15. Okay, so we still have more than 2,000, so maybe we should try x equals 8. So let's do $2,097.15 and multiply that by 0.8. And there we go. We have $1,677.72. So it looks like we'll say at least 8 months. In 8 months he will have less than $2,000. Or how about this? In about 8 months. He will have less than $2,000. Okay, all right, and we're going to simplify these. 4 to the 0 power, anything to the power of 0 is 1. 3 to the negative 2 power, remember, any negative power, you're just going to flip it. You're going to put a 1 in the numerator. You're going to bring down exactly what you have. So now I have 3 squared in the denominator. And this leads me to 1 over 9. And that's your answer. You can't read this. This says 4 to the 5th divided by 4 to the 2. Are the bases the same? Yes, they are. If the bases are the same and you're dividing, all you're going to do is you're going to subtract the exponents. So we are left with 4 to the 3rd power. And then we have 3 squared to the 3rd power. When you raise a power to a power, you're going to multiply these things. So now you have 3 to the 2 times 3 power, and this gives you 3 to the 6th power. Okay, this x, I know it's kind of misleading, but that means to multiply. So we're in scientific notation here. So essentially this is what's happening. 2.3 times 10 squared times 4.6 times 10 cubed. Let's group together the 2.3 and the 4.6. Let's actually multiply those two things. So 2.3 times 4.6, and you get 105.8. Okay, and I want to leave my answer in scientific notation, so I need to now combine 10 squared and 10 cubed. They have the same base, so therefore we're going to add the exponents together to get 10 to the 5th power. And that is your answer. And that's it. Awesome. All right, well, happy studying, you guys, and good luck tomorrow.